Bismillahirrahmanirrahim. Assalamu alaikum viewers and welcome to my channel, and in today's video we are going to discuss the property of your beta function, which is this, that is the beta function of your L and M is equal to the beta function of your M and L. Like if you simply swap these two real positive numbers, nothing is going to affect on the function. In the previous video, we discussed the relationship between beta and gamma function in quite an exhaustive way, and we tried our level best to penetrate ourselves as deeply as we can in that derivation. So those who have watched that video, I hope they are very much helped. Now over here in this video we are going to discuss this property, and we are going to solve it numerically, and we are going to show that this beta function is equal to this beta function. Means the order of the real numbers, positive real numbers inside a beta function is not going to affect the result of this function. Okay, so you know well that the formula of your beta function or the definition of the beta function is expressed with respect to this integral that you call beta integral. Okay, and remember that the number which is written first inside the beta function, that number is written once when you subtract 1 from that value L, it behaves as a power just on x. Okay, and the second number, when you subtract 1 from it, it is going to behave with a power on the base 1 minus x. Okay, so you have to maintain, you have to keep this thing in your mind, that which value is going to be placed on which base. All right, so this is it. Excuse me. Now what you have to do, you see the powers are very much clear. The upper and lower bounds, or the upper and lower limits of your integral is very much understood with 0 and 1. Now before moving ahead and before proving this beta function equals to the beta function of ML, I would like to discuss one major property of your definite integral, a single integral, and it is this, that if you're having a limits like this, and a is any real number, positive real number, then whatever, if you're having an integrand of this nature and you're evaluating it and you're solving it, then you're applying a limit, you're getting some answer, and this answer will be same if your integrand with respect to the same limits, if your integrand is of this form. Okay, but it's of this form. All right, so you see over here the value that I have written is similar to the upper limit of your integral. Let's take an example over here and try to understand that, and then we are going to come back over here at this stage. Okay, so suppose that my f of x is simply x. Let us try to understand as simple way as we can. So let your f of x is your x, all right, and f of a minus x, for example, just like that, it is a minus x. Okay, whatever the value over here is going to be substitute wherever you find the variable. At the place of that variable, you are going to substitute this value, and that's what we have done over here. Okay, now first of all, let us integrate this function with respect to the limits, this, okay, f of x dx. Okay, so integral of your x dx is going to give you x squared upon 2. all right, so once you apply the limits, the upper limit is going to be applied first, the lower limit afterwards. So the answer come out to be a squared upon 2, and you just save it. Okay, now just come over here and let's integrate this function with respect to the same limits, and we should get this answer, the same answer. So if I just integrate my f of a minus x, and over here I have defined this function as this, okay, dfx. Okay, so now you can separate it out. Okay, so this is a constant value, so I'm going to write it outside the limit. Outside the integral, I must say, sorry. This is it. So that's why it is now going to be x times 0 and a minus x squared upon 2, 0 and a. Alright, now I'm going to apply my limits here. So let us take a new page. Why should I take a new page? How about if you just that's better. Okay, so so let us apply the limits. It's going to be a minus 0 minus, and it's going to be a squared upon 2 minus 0. Alright, this is it. Now let us simplify. It's going to be a squared, and there's nothing, minus a squared upon 2. Then you simply take the LCM of it. It's going to be 2a squared minus a squared. I hope you're well aware how to take out the LCM, or how to add or subtract the fractions. So you see, you are having same answer once you integrate this thing, and it is similar to this answer once you integrate this integral. Okay, so this shows that whatever the integrand over here with respect to these limits, if you just replace this variable x, whatever the definition of the function is, wherever you find your x, you're going to replace that x with your a minus x, and then you integrate that integrand with respect to the same limits, you're going to get the same answer. So I hope it is now this entire thing is now clear to you, and we are using this property right over here. All right, now as you can see here, when we just fuse this property over here in this integral, all right, excuse me, at the place of your a, you are having your 1. The upper limit of the integral over here is 1. Okay, so, and this is your entirely your f of x. And once when you replace your x by your 1 minus x with respect to your a is 1 here, so over here you are going to replace your x with your 1 minus x. So in the definition of your function f of x, wherever you are having your wherever you are having x, at that place you are going to put 1 minus x. Okay, so I'm going to replace this function by means of this, okay, in beta function. So let us write down. So the beta function Lm, which is actually this, I'm just fusing this property over here. Okay, same limits. Wherever I'm having my x, I'm going to put it 1 minus x over there. Okay, let me open a new bracket. 1 minus, and at the place of my x, I'm going to put down 1 minus x. Okay, and close the bracket, and it is m minus 1 d of x. Okay, this is it. It's done. Now let us simplify the integrand. Now we are almost getting closer to our property proof. Now let us open this bracket. It's going to be 1 minus 1 plus x. Okay, because minus plus gives you minus 1, minus minus plus x, that's how you get, and the power is the same. Okay, then plus 1 and minus 1 gets cancelled. So over here you're having x power m minus 1 left, and this thing is going to be written afterwards. Okay, so I told you in the beginning that whatever the power you can observe just on x is going to be written first in the gamma function, in the beta function, sorry. Okay, and the power which is written on the base 1 minus x, that thing is going to be written right after this value inside the beta function. And that's it. So you see, beta of your Lm is equal to beta function of your Ml. So that's how you just come up with this major property of your beta function. Alright, so that's all for today, and in the next video we are going to discuss the transformation of your beta function. So I hope you have understood this property. So if you find this video helpful, I humbly request you to subscribe my channel, hit on the like, share this video as much as you can, and you can share it on social media as well, so that the others can also be helped and their concepts will also get cleared regarding this topic. Okay, so take good care of yourself. Allah Hafiz.